degassing contaminated water. Before we get into our presentation today, I do have just a couple quick housekeeping slides to go over. Hopefully you should be able to hear me speak, but I do want to mention just that should you have any difficulties throughout the presentation today, there are two different ways to connect to the audio. You can connect either through your computer or call in through a phone line. And also, due to the large number of attendees on today's presentation, we have gone ahead and muted everyone's line, but no worries on that. You can still interact with our speaker. And in terms of interacting with our speaker today, you can ask your questions through the questions panel over on the right-hand side anytime throughout the webinar. And at the end of the presentation today, we do have some time set aside for a Q&A session. So please feel free to ask any questions that may come to mind throughout the presentation, and we will try to get through as many of those questions at the end of the presentation as time allows. Additionally, we have gone ahead and made available our collection of on-demand webinars that we've conducted over the last few years. You can access more than 60 on-demand webinars over at www.veoliawatertech.com. So feel free to go over, browse the website, and browse through any of those topics to see if any of them may be of interest to you, and watch those at your convenience. A PDF participation certificate will be made available to you at the conclusion of the webinar today. You should receive that within about 24 hours or so at the conclusion of the webinar, so please feel free to watch out for that in your email if that's something of interest to you. Additionally, at the end of today's webinar, you will receive a quick survey requesting your feedback. It should take no more than 20 to 30 seconds of your time. And for those of you who do complete that survey, you'll be entered into a drawing for a chance to win a $25 Amazon gift card. So if you would be so kind as to fill that out for us, we do greatly appreciate any and all feedback. Now, before we hop into the main part of our presentation today, if you are not familiar with Veolia Water Technologies, we are a leading water and wastewater technology provider, and we offer our clients a variety of technologies, services, chemicals, and project options to support clients' water and wastewater needs. To learn more, feel free to go over to that website again, www.veoliawatertech.com, to learn more. So with that, I would now like to introduce our speaker for today's presentation. Afonso Araújo is a process engineer with Veolia Water Technologies. He holds a degree in mechatronics engineering and has been in the industrial field for 6 years. He has focused his career on water management and industrial water treatment. And with that, I would like to now turn the floor over to Afonso. Welcome, Afonso.
Thank you, June. Welcome, everyone, once again, and thank you for being here with us as we talk a little bit more about the Costrip technology, a gas removal solution provided by Veolia. When we're talking about water treatment, we often face the presence of dissolved gas, and this can be an obstacle in different processes. Acid gases are toxic and highly corrosive. When you have this kind of gas dissolved in your effluent throughout pipelines, valves, equipment, that is not good news for the maintenance team or the process in general. Also, volatile organics are strongly regulated by national agencies. If we look at the benzene, for example, there would be a limit for exposure in an atmosphere of 1 ppm by volume for an 8-hour period. For various reasons unique to each process, we will need to remove this dissolved gas. And when we look at that, one of the solutions are the vacuum towers. These towers use a vacuum to facilitate extraction of these gases. Unfortunately, this same vacuum is highly susceptible to falling by oil, grease, and suspended solids. And because of that, often we will be required to install some kind of filtration, de-oiling process upstream of this equipment. And looking at that, Veolia came up with the Costrip technology. We took the same tower and tilted it horizontally, removing some of the height work related to that. And instead of relying on the packing, we use the injection of micro bubbles, excuse me. As these micro bubbles are injected inside of the water body that is being treated, and they act like sponges, dragging in the contaminants and bringing it up to the headspace that is constantly replaced with new gas. The vessel is sectioned in 4 cells, and for each cells we're gonna have a different gas in the same gas injection, but 4 stages for this gas for this removal. Taking a closer look at the disequilibrium first outlined by William Henry back in the 1700s, this disequilibrium will force the contaminants to migrate within the bubble. This bubble will go up to the body, will come to the headspace, and as we constantly induce new fresh bubbles, this constant removal rate will be maintained. The law that makes this possible states that at a constant temperature, the amount of gas that dissolves in a liquid is directly proportional to the partial pressure of the gas in equilibrium with that liquid. And what that means, looking at this little draft on the right-hand side, is as we're injecting gas free of the contaminants inside of the water, a disequilibrium will be made, and to breach back to equilibrium, the dissolved gas will want to migrate to within this bubble. The bubble will make the way up, and we're going to swipe that away. And because of this principle of functioning, as we increase the injection of microbubbles, we will increase the rate of removal for the contaminants. And due to the principle of operation for this law, where the concentration is independent of the ratio, the only thing that is actually influencing the amount of gas that is removal or that migrates within the bubble is the Henry's constant that is tied to the temperature. So because of this independence between the ratio and the concentration in the effluent, Costrip is a great solution either if you need to remove thousands of ppm or if you're looking to polish down effluent down to the ppb's level. Over here we have 2 graphs showing what is the efficiency, and just making a quick example for that. We have on the x-axis the amount of gas that is being injected inside the vessel, and on the y-axis the removal percentage. On the left-hand side, we have the carbon dioxide removal chart for water 160 Fahrenheit. And just to use it as an example, for a 10 cubic feet injection per barrel being treated, we can achieve something over 90% removal. And on the right-hand side, we have the hydrogen sulfide, and for the same 10 cubic feet per barrel, we're gonna get to an 80% removal rate. And as I mentioned before, the constant rolling, this equilibrium is tied to the temperature. As the temperature rises, the value of this constant also increases. And as we can see down here, for lower temperature, a fraction of the dissolved gases will want to migrate to inside the bubble. And as we observe a rise in temperature, if possible, more of the contaminant will migrate within the same bubble. Once again, we come to the graphs, and now we are looking only to the carbon dioxide removal chart. at different temperatures. On the left-hand side, we have 160 degrees Fahrenheit, and on the right-hand side, we have 80 degrees Fahrenheit. And for the same 10 cubic feet per barrel, we can look at over 90% removal, but when we go down to 80 degrees Fahrenheit, the injection of the same 10 cubic feet will provide us a removal of 70%. This can be quickly fixed, if that's the case, by increasing the amount of gas that is being injected. If we go up to 20 cubic feet, we come back to the 90% removal rate. Another important item to be aware of is the chemical equilibrium dependence. As we are operating over absorption-based process, the pH is a very important variable. We need to make sure that the dissolved gas are actually in the gaseous species when we are operating the Costrip. And to do that, we need to observe a lower pH level. And for example, over here, we can look again to carbon dioxide, that to remove that, we would target a pH level from 6 to 6.5. If for hydrogen sulfide, we would target from 5 to 5.5. For each different gas that we are targeting removal, we will have a slightly different pH, so don't hesitate to contact us when thinking about your next application for gas removal. And another ability for the Costrip is providing alkalinity reduction. And that comes, for instance, if we think that for every CO2 molecule that is stripped away, a bicarbonate ion was converted to the same CO2. And when looking at that, for any process that require pH adjustment, we will see significant cost savings. And changing a little bit the focus to the utilities required for the operation of the Costrip, the principal utility would be the stripping gas, and we don't have a lot of restrictions when it comes to that. The most important is that the gas being used as a stripping gas cannot present significant amounts of the target contaminant. Besides that, we can use a variety of different gases. And one can ask, what do we do with the gas after passing to the Costrip? In fact, there's no magic. When we are removing this contaminant from the water and bringing it up to the gas, we will need to treat it. And a few options are flaring, amine treatment when it's available in the plant, chemical scrubbing, thermal oxidation, biofilters, or sulfothane for the H2S treatment. And as we approach the end of this presentation, I would like to share this case study with you, where we had the opportunity to run a pilot test for produced water and flowback waters that would present the contamination of H2S from concentrations from 400 ppm to 600 ppm. The test results showed that 75% removal at 70 degrees Fahrenheit, the pH at 5, and an injection of 30 cubic feet of stripping gas for each barrel. As we estimate that as we increase this temperature, we would be able to get 80 to 85. And looking at the cost-saving opportunities, if we're looking at the regular chlorine dioxide for oxidant to remove the same H2S or manganese and iron, the Costrip would allow us a saving of 50 cents per barrel when looking at the 10,000 barrel per day at 100 ppm H2S. Another thing that is nice to point out is that the Costrip is ready to plug and play with a 10,000 BP barrel per day shallow flow equipment, which is Veolia mobile solution for produced water treatment. And as we get to the conclusions for this presentation, I would like to go over a quick recap about what we talked today. So the Costrip is an absorption-based stripping that provides a unique pollen-resistant solution, removing any kind of pretreatment. And we can operate this equipment for a variety of different dissolved gas, and we do not require any specific stripping gas as long as we don't see the contaminants in its composition. We were able to pilot test this solution, and we show over 80% of removal for all dissolved gases. And for who wants to look at these in a more detail, we have a white paper published for the SPE at this number that we can see on the screen. It's a great paper that goes down to every single detail of this application. The removal rate is easily adjustable, as we mentioned before. We just need to adjust how much gas is being injected. And since we can apply the Costrip at the very beginning of your treatment line, we provide a safer use on the downstream equipment since we will not contaminate it with acid gases or toxic gases. A part of a chemical softening train, Costrip lowers chemical consumptions, which generate cost reductions. And we also noticed that when you install the Costrip upstream of a membrane-based filtration, it will improve the lifetime for these membranes. Jill, this was our presentation, and I'm gonna turn it back to you for the Q&A section.
Great. Thanks so much, Afonso. Just a reminder, if you have any questions, feel free to type those over in the questions panel. And with that, we'll kick off this Q&A session. I'd like to also introduce on the call today, Oscar cannot speak today, Oscar Valestigui, who is our technology manager. He will be joining us for this Q&A session. So with that, I will kick it off with, let's see what we've got coming in here. What types of off-gas treatment do you have in mind or have you encountered on previous projects?
Yeah, and the options that we have for the off-gas treatment really go around the flaring, the amine treatment. We do have biofilter systems and also the self-obtain. Oscar, if you want to provide a little more detail on these.
It will depend what I guess the site already has available. Sometimes the sites already had available a BRU, which is a vapor recovery system. So we'll take advantage of that if they already have that in place. And if they don't, then I guess the treatment systems that Afonso mentioned are some options that you guys can have. Sulfothane is Veolia technology, so we can couple that in, and it's exclusively for H2S treatment.
Great, thanks. Another question that came in, to increase dissolved gas removal, would the vessel have more cells or would the amount of gas per cell be increased?
That's a great question. And for increasing the percentage of the removal, our first action is indeed increase the air injection and making sure that we have the right pH at the inlet and that we are pretty much air injection.
Great, thanks. Another question that came in. Could you please elaborate more about the chlorine dioxide injection at site and talking a little bit about that?
Oscar, would you take this first?
Yeah, no problem. So typically on the produced water applications, you use an oxidant to be able to remove different contaminants. One of them is, I guess, H2S, right? So people would just dose that to be able to remove this contaminants. The other one would be hydrogen peroxide. We've seen that that is also used to be able to drop the regular contaminants that people have on the produced water system, so they are able to reuse for fracking operations.
All right, another one that came in here is, can you use air diffusers instead of water recirculation to reduce the energy consumption?
We are able to use that without any issues. The only problem that we've seen with that is that produced water, in this case produced water, is very contaminated and it has a lot of scaling. So varying that, the diffusers, I guess, don't have any problems with it, then we should be able to use that as well. We rather have something that doesn't give us a lot of problems in the field. It doesn't have the tendency of either get damaged or get plugged while we operate the unit itself. That's the reason we use, I guess, an inductor-based system to be able to induce those bubbles into our unit.
Great. Another question that came in is, can the Costrip be used as an oxygen removal? Let's start that one again. Can the Costrip be used as an oxygen removal from water before feeding a boiler?
That can be used, yes, but you have, I guess, other technologies that you can use on that. One of them, I guess, that Fonso presented initially, which is a regular packing tower. Usually for a boiler, you'll have pre-clean water trying to remove the oxygen. So Costrip is intended, I guess, primarily when you have, you start with very contaminated water with high solids, hot oil, where you can use this to be able to remove this gas initially and avoid a lot of problems downstream. In this case, you already start with pretty clean water, so because the vacuum tower will probably be the preferred option here.
Another one is, by which mechanisms gas injection can be adjusted depending on oxygen concentration inside the ponds?
You can adjust, I guess, the concentration of the gas being injected in the unit. Many times what we do is we look at what is coming in into the unit. So if there is any variable flow that you might have coming into the unit, then we have ways to vary the air injection as well.
Great. A secondary follow-up question on that as well is, how can you achieve, or how do you achieve balanced gas concentration in water ponds and wastewater treatment units, such as MBBRs or MBRs?
That one, Jill, I don't fully understand the question. We can probably take it offline with the person that asked this and provide some more details about the question, and that we can probably answer, I guess, correctly instead of trying to guess what was that question. Yes.
Sure, absolutely. Another one that we've got here as well is, what effects does the fluid temperature have on the removal rates? And then follow up to that is there a minimum temperature requirement in order to make it economically feasible?
That's a great question because temperature has a lot to do with this separation and this performance of this unit. So what is the minimum temperature required? I will answer that with saying, what is the hotter water or liquid that you can send to us, because that will be the hotter, the better. I've seen that the unit performs best at probably 140 degrees F and better. Not that it doesn't perform, I guess, stellar below that, but you just have to put more gas in it. So as the temperature goes down, you have to increase the amount of gas to get the same performance.
Great, thank you. Another one that we've got here is how is the air injected into the Costrip?
So we have different ways of doing this, but one of the ways that we can inject this is using eductors and using the effluent water of the unit to be able to get the motive flow and pressure needed to drive those eductors and drive the gas into the unit itself.
Okay. Another one that just came in here is how can you avoid formation of black powder deposits?
Formation of black powder deposits. That would be another one that we can take it offline. Okay. But one thing that I want to say about that is that because there is a high turbulence inside this vessel, most of the contaminants coming into the unit, they usually get out. There's a lot of turbulence going on inside the unit, so they don't have time to settle. And because they don't have time to settle inside the unit, then they usually just pass through.
Okay. Another one that we've got here is, what are the flow ranges and concentration limitations for standard units that can be sized offhand? Excuse me.
So we have different, I guess, size of units that are already standardized in our library. So depending on the flow rate and the amount of performance that you would like this unit, I guess, to do, they will choose one of these standard, I guess, models that we already have pre-engineered.
Okay. Got another one that came in here is, what gas would be used to strip BTEX in an oil and gas application?
The only requirement for the gas to use, let's say for BTEX in this application, is that the gas himself does not have any BTEX in it. The performance Henry Lowe's constant or the technology that we use is heavily depending on the stripping gas not having the contaminant that we need to remove. So it could have any other contaminants. It could have CO2, it could have H2S, but if you're trying to remove BTEX, it should not have that contaminant in the gas.
Great, thank you. Looks like we've got one more question that just came. Have you tested the efficiency of oil and TSS removal in this specific configuration? And if not, are you planning to do so?
Yeah, so the unit, the primary purpose of the unit is to be able to remove gas. It can also remove oil and solids at the same time. But it will be, I guess, a reduced performance compared to other equipment like an induced gas flotation unit. And the only reason it will be a reduced performance is because there is high turbulence inside because of the amount of gas being injected inside this unit. So we can obviously pilot test all of this and just hone into the exact performance based on the application that we have to do.
Great. Got one last question. It looks like that just popped up. Would it be advisable to inject sulfide scavenger in upstream?
Not necessarily. What I've seen, I guess, people do at the very end if they want I guess a higher performance that what our unit can do, is that they will actually treat this fluid in the downstream instead of the upstream. The main purpose of this is to try to reduce the consumption of chemicals on this and treat it in a different way.
Perfect. Well, thank you both for that very informative presentation. I don't think it looks like we've got any other questions that are coming in at this time. For those couple questions or a couple people that asked those questions, we'll follow up directly with you guys as well. Do want to thank everybody for their valuable time today, spending it with us. And again, at the conclusion of the webinar, we do kindly ask if you would take that brief survey for us, and if you are selected to be the lucky winner of the $25 Amazon gift card, we will follow up directly with you at the conclusion of the webinar today as well. So with that, it concludes our webinar, and we do thank you all for your time. Thank you very much.